Okie dokie, let's get ready for the exam. I know there's a lot of material on it. And the first thing I am going to show you is how to use the solubility rules, which will be provided properly to come up with the molecular equation, the net ionic equation, and the complete ionic equation. So here's an example of two aqueous solutions, lead nitrate or lead 2 nitrate and potassium iodide. And you get this yellow precipitate when you mix these two solutions. And you are supposed to predict this reaction based on this chart here. And so I'll go through that in a minute. But what you will be asked is to provide the molecular equation, the complete ionic equation, and the net ionic equation. And I will show you how that works here with an example that's going to be very close to what you will see on the exam. Ionic and covalent bonding is a prereq for that. You need to know the difference and why ionic compounds form aqueous solutions. You need to know the chemical formulas of these and why they are what they are. For example, if you have lithium chloride, it's in a 1-to-1 ratio, but if you have calcium chloride, it's in a 1-to-2 ratio. You should also be able to name these things, and you need to understand how polyatomic ions fit in with ionic compounds. If we have, for example, lithium carbonate or calcium carbonate, the formulas, the names, and if these are aqueous, so this would be aqueous, this is aqueous, this is aqueous, and this actually doesn't dissolve in water. It's a solid. Knowing how that works and knowing what those phase labels mean. But so I don't want to review all this. I'm going to go straight to business here in a second. But I do want to highlight one little thing. If we have aqueous solutions, what that means is we have ions that are free to move and they're attached and surrounded by water molecules because water is polar. And so what that means is that lithium carbonate, for example, exists as lithium ions and carbonate ions. And both of those have charges. This 2 here means that we have 2 lithium ions. And the only reason we have that 2 there, just like the only reason we have that 2 there, is that we have 2 ions per unit. And that comes back to understanding ionic and covalent bonding and chemical formulas, and knowing that the predetermined charge of calcium is +2, the predetermined charge of chloride is -1. So this is perhaps a good review for you. So here are the solubility rules, and you need to be able to understand them. The top part is ions that are all soluble. And then in this column here are the exceptions. So all nitrates, all acetates, all lithium, sodium, potassium, and ammonium compounds are always soluble. How did I know that this is called nitrate and acetate and ammonium? I have access to the polyatomic chart, and you will as well. You just have to make sure that you know, well, there's more than 1 atom here in the formula. That means it's got to be a polyatomic ion. But enough of that. We'll go back to this here in a second. I may ask you on an exam to provide the molecular equation, the complete ionic equation, and the net ionic equation for the reaction of aqueous lithium carbonate and copper 1 acetate. Include all phase labels. So number 1, I give you the names. So you need to know that lithium is Li, and carbonate is a polyatomic ion, CO3. But that's not good enough. There are 2 things missing. Lithium has a +1 charge. Carbonate has a -2 charge. That means I need to have a little 2 here. Lithium carbonate. Also the phase label. It's aqueous. I tell you it's aqueous. So you put AQ. Again, that means that we have free-flowing lithium and carbonate ions. In the other solution, we have copper ions and acetate ions. And the Roman numeral, of course, indicates that this is copper 1 acetate is -1 C2H3O2. So this is in the 1-to-1 ratio, and we're good. So we have copper acetate here, aqueous. If you look at the solubility rules, and you can do this one of many things, but you can find that acetates are always going to be soluble. So you know that the product that is formed, and you know lithium also doesn't have any exceptions. So you're going to make lithium acetate and then copper 1 carbonate. That's the other compound. So we don't have the, yeah, we do. So carbonates are insoluble, and so the question is copper an exception to that? Because we're going to make copper 1 carbonate, and the answer is no. The exception, in fact, comes from this rule up here. So if we go back to this problem, we can now have the solution. We know that copper carbonate, copper 1 carbonate, is going to precipitate out. So you need a solid phase label. But I'm not done, because copper is +1 and carbonate's -2. So I have to fix this formula by putting a little 2 here. It's copper carbonate. Copper 1 carbonate has this formula and has this label. This is what's going to precipitate out a solution. That's going to form an insoluble solid. And the other product is lithium acetate. And that's in a 1-to-1 ratio because lithium is plus and acetate's minus. So this is simply aqueous. We can balance that now. So we need a little 2 here and we need a little 2 here, and we are balanced, which will make our next step, the complete ionic equation, a little easier. So this is your molecular equation. Next we need to pick everything apart. Everything that's aqueous, it has independent ions. So we take the cation and the anion and we list them separately. So lithium ions, there's going to be 2 lithium ions, 2 Li plus. Now, active is going to require you to put a phase label there. I will not require you to put a phase label next to a charged particle. So the only phase label you need is the solid. And the reason for that is I'm going to run out of space in this line if I put a phase label everywhere. But you know, technically this is a Q, just to make sure. So we have lithium ions, 2 of them, and we have carbonate ions. Then from copper acetate, copper 1 acetate, we have 2 copper ions. Need the charge, and 2 acetate ions, C2H3O2 minus. See, I'm already running out of space. This is solid, so it stays together. Copper 1 carbonate. This is what's precipitating out. And then this is aqueous, so we have 2 lithium ions and 2 acetate ions. Alright, don't forget the charges. You should see right away that we have free lithium ions on both sides. Those are spectator ions. They drop out, and so does the acetate. Those are called spectator ions. So you end up, and I'm going to put the metal first, just, you know, just because I like it. So we have copper, and I'll put the phase label this time. Again, you don't have to. And carbonate are the 2 species, the ions that are reacting to form a solid. So they turn, they bounce into each other, and they precipitate out. Copper, carbonate, solid. And so here it is important to have this phase label here, okay? And of course the molecular equation is going to have all phase labels. So this is hard because I'm giving you the name. You have to know the formula, okay? Or you cannot do that, and that's important. And So here's another example, and I'll work that one real quick. Now it's lithium carbonate and silver acetate, so it's basically the same, except I've switched the silver ion out with the copper, so this is the same thing, but it's kind of cleaner, same idea. And okay, let's move on to the next tutorial.